We do.
Everybody breathes.
Hold our breath for 10 minutes and we'll solve that problem.
Good evening, everybody. We have Terrie Boguski with us this evening talking about developing greenhouse gas inventories. And Terrie has her own company, Harmony Environmental, and she also works here at the K-State Center for Hazardous Substance Research. So she has two positions. She's part-time with us and part-time with her own company. And Terrie started here as a student at Kansas State University, and because of some personal reasons, she left here when her husband graduated. And so she finished her education elsewhere, but we found her, and she's been working with us for a number of years. And she has a lot of experience with life cycle assessments, and now she's working in developing greenhouse gas inventories. And at dinner tonight, she said that her company is looking for somebody to work in life cycle assessments and looking for people to work in that area. Terrie, we're happy you're here, and we're looking forward to what you have to share with us, so please go ahead.
Thank you, Dr. Erickson, and thank you all for being here tonight. I think it's great that we're having a seminar on sustainability. It's a topic that we all need to pay a lot of attention to. And my talk is a bit of an introduction on some of the ways to measure and look at climate change and global warming. And so I'm going to talk about carbon emission estimates. Can everybody hear me? Because I have a soft voice, and if you can't, just start waving at me or
Move closer.
move closer. There are plenty of seats up front. Also, if you have a question, a comment, you want to add some information or material to what I'm talking about, please do that. I'd like this to be very informal. So I'm going to talk about what are carbon emissions, why do we want to estimate them, and then how do you go about making those estimates. And as Dr. Erickson said, in the life cycle assessment field, when we're looking at products and processes from cradle to grave, looking at what energy is used and what emissions, what solid waste, the greenhouse gases have always been data that we've collected. But with climate change and our sustainability efforts, there's a lot more focus on it. So this field is growing and moving, and it's hard to keep up with everything that's happening in the world and the United States about this topic. So I'm giving you a little bit of what's out there, but there's a lot more. So carbon emissions, generally, when people talk about measuring their carbon emissions, they're referring to greenhouse gases resulting from human activities. You're talking about gases that trap heat from the sun and the Earth's atmosphere and contribute to the greenhouse effect. And human activities that are contributing to climate change and global warming are burning fossil fuels. There are emissions from landfills. There are certain industrial processes that release fossil carbon dioxide. For example, making lime from limestone, you're taking calcium carbonate, making calcium oxide, so you're releasing carbon dioxide that has been part of the rock for millions of years. So these types of activities are contributing to global warming. The common greenhouse gases that are being measured at this time are carbon dioxide from fossil sources. If you have carbon dioxide from non-fossil sources, those tend to be left out of the measurements. For example, if you burn wood, the current thinking is that you plant another tree, so the CO2 that you're releasing is taken up by the natural system and it becomes part of a recirculating system, versus taking crude oil out of the ground, which has been stored for millions of years, and taking that carbon that has been in the earth and putting it into the air. So we're measuring carbon dioxide from fossil sources. Methane, nitrous oxide, sulfur hexafluoride, the hydrofluorocarbons, and the perfluorocarbons. CFCs tend to not be measured because the driving force for measuring your carbon emissions is political and international treaties, and we have the Montreal Protocol for helping to reduce our ozone depleting chemicals, so though they're not trying to double up here with the same effort. Sure.
Yeah, they're not really that strong greenhouse gas. I mean, they're breaking down our ozone, but they're not like heating it.
That's true too. So why estimate the emissions? As I mentioned, there are international treaties that, if you're a party to that treaty, require it. Some states are starting to mandate reporting. There are companies that want to do voluntary reporting because it's the right thing to do. There are companies that want to do voluntary reporting because they think it gives them a marketing edge. There's also potential federal regulation looming. So the international treaties, there's the United Nations Framework Convention on Climate Change. And most countries, including the United States, have joined that treaty. It came into force in March of 1994. That treaty requires the participating nations to publish national inventories on their greenhouse gases and to begin programs to mitigate and adapt to climate change, but it doesn't force anybody to reduce their greenhouse gas emissions. The U.S. does have a national inventory. It's prepared annually by the EPA, and I've put the URL here. I know you may not want to spend a lot of time copying that down, and I think we can make the slides available if you talk to Dr. Erickson later if you want that information. But we do have an annual inventory. Yes?
So we signed up for this treaty, but we're not cutting back on our emissions. How does that work out?
Well, this treaty doesn't require it. It requires the reporting, and it requires programs to mitigate. And the EPA actually has some programs, and later in my presentation I have the website for some of the EPA initiatives, and the STAR program. They have some partnerships with businesses, so it's all voluntary, and there are really no teeth in it. And the treaty that, in addition to this treaty, is the Kyoto Protocol. That does have teeth in it. If you're a member of the Kyoto Protocol, then you're an industrialized nation, you have a requirement to reduce your greenhouse gases. Well, the United States has signed the Kyoto Protocol, but the United States has not ratified it, so we're not legally bound to reduce our greenhouse gases. And there's a website if you want to read the Kyoto Protocol also, and get more information about who's a partner and who's not. The European countries in general, most of them are a party to the Kyoto Protocol, and therefore the European community is taking steps to reduce their greenhouse gases. They're taking steps for carbon trading. And then you see that in the United States you have some voluntary carbon trading going on, like the Chicago Carbon Exchange. But it's all voluntary here. With the lack of federal leadership and mandates, some states are looking at the climate change, and they're very serious about the effect that this is going to have globally. And some states are mandating reporting. California has a Global Warming Solution Act. New Mexico has started requiring greenhouse gas emissions reporting. Oregon has a rule proposed. Washington has a rule proposed. Kansas requested a GHG inventory from facilities that generate 10,000 tons or more of CO2 equivalents, and they started that last year. This is not a complete list, and there are other states that have mandated reporting already that started earlier. This is just a sample of some of the things that are happening with states. California's been very active. For those who want to report voluntarily, in North America there are three main organizations that are handling registries of reporting registries, and the climate registry is the one that seems most active and is out there, and I really expect it to maybe take off and be the national registry for us at some time. I think EPA is already partnering or supporting in some way the climate registry, not financially. I don't know about that, but just looking at it. The Department of Energy has a voluntary reporting system, and then there's the California Climate Action Registry. And then we have potential federal regulations that are out there. They'll probably happen at some point. As I said, the EPA currently has greenhouse gas reduction initiatives are all voluntary. They're programs to help people voluntarily reduce their greenhouse gas emissions. But there is a bill that's been proposed, and it's in committee right now. And if you want to read about that bill, there's a very long website, but you could probably also Google Greenhouse Gas Registry Act and find it a little easier. So that's kind of the state of where we are with reporting mandates and legislations. Anybody have any discussion or questions? Any other information that I haven't covered? So on, if you're going to measure your greenhouse gases, it's important when you start out on a task like this to spend some time knowing what you're going to measure and why you're going to measure it. And for the United States, they're estimating greenhouse gas emissions for their report for the UNFCCC treaty. So, they have a method and a way to do that that meets those requirements, and they know how they need to report and into what detail. I have, in my work, talked to people who've been a little bit confused about carbon emissions versus a carbon footprint versus a greenhouse gas emissions inventory. I read some reports that report so many tons of carbon emissions, and they really are reporting carbon, C. But then I have the more common way of reporting is to report your greenhouse gases in carbon dioxide equivalents. And so when you're reading reports or trying to gather information on different things that have been done, it's good to kind of pay attention to the units. And if somebody says carbon emissions, then you need to ask the follow-up question, well, how is it measured? Is it measured in carbon? Is it measured in CO2 equivalents? And then also, know what global warming potential factors you're going to be using. And your global warming potential is a way to put the emissions of different chemicals on the same basis of carbon dioxide equivalents. So methane, for example, has 21 times more heat holding capacity than carbon dioxide. So if you put a pound of carbon dioxide in the air and you put a pound of methane in the air, that's the same as putting 22 pounds of carbon dioxide. So that's how the reporting is done to get your emissions into the same terminology so that you can compare different systems. So the point I wanted to make with this slide is that, again, watch whether you're measuring tons of carbon or tons of carbon dioxide equivalents. And then also, tons are a terrible unit of measure. They always cause problems. And in the U.S., we do tend to measure things in U.S. tons. And when I go to a company and I'm collecting data, I need to take that data in the form that they have available. I have not run across a company in the U.S. who has ever given me data in metric tons. But the Kyoto Protocol and the greenhouse gas protocol standards, the greenhouse gas protocol initiative standards, they all ask people to report in metric tons because the rest of the world is metric. So you have to just watch your units very carefully when you're doing these studies so that you are converting everything and you understand what data you're getting in and how you need to handle the calculations. So again, the UNFCCC and the Kyoto Protocol require the greenhouse gas inventories in metric tons per year. And then the Intergovernmental Panel on Climate Change, the IPCC, has put out 3 different reports. The second assessment report in 1996, and then subsequently they put out the 3rd report and the 4th report. Each report has a different list of global warming potential factors for the different greenhouse gases. So in 1996, the factor for methane was 21. The factor for nitrous oxide was 310. In the 3rd report, I think it was 25 and 296, and I think now it might be 28 and 200 and yeah. So exactly. So some of my colleagues have been, well, we're going to use the latest and greatest numbers because that's the right thing to do. But if you go back into the policy, to the policymakers, it's like, no, we wrote these numbers into the protocols, so when you report, you need to use the SAR, the second assessment report numbers, so that you're consistent with everybody else. So that's going on also, and it's good to use the numbers that everybody else is using. Otherwise, you don't get a good comparison compared to your competitors, perhaps, especially if you're doing this to see if you can improve your green appearance as a company. So if you're going to do a greenhouse gas inventory, there are 6 basic steps. One is to set your boundaries. What will the inventory include? What will it not include? Identify within your boundaries what are your sources of greenhouse gas emissions. Fuel combustion, process emissions, transportation. Then you need to determine what's my approach to calculating my greenhouse gas emissions. So once you get all that upfront work done, then you collect the data. And you need to do this upfront because data collection is very expensive, it's very time consuming, and you don't want to collect data that you don't need, and you don't want to get down the road on a study and find out that you need data that you didn't collect. So planning is everything. It's the same as if you were planning a construction process. You'll measure twice, cut once. So you want to plan well and then do your data collection following that plan. Then you calculate your results and report your results. Generally, the ISO standards on greenhouse gas inventories and the climate registry, the California climate registry, from what I've read, they all are very similar in how they're setting up. The Greenhouse Gas Protocol Initiative standards and tools are acceptable to the ISO standards. The ISO standards came later. So the boundaries are divided into definition of Scope 1, Scope 2, and Scope 3. So your direct emissions from your sources that are owned or controlled by your company. So if you're at a paper mill, you have a facility the fuel that you're burning at that paper mill would be your scope 1. Scope 2 is very narrowly defined. It's your purchased electricity, heat, or power. And that's the only thing that goes into scope 2. Scope 3 is everything else, whatever you want. So if we were going to do a greenhouse gas inventory of the university, our scope 1 would be the fuels that are used at the university, on university property, controlled by the university. Our scope 2 would be the electricity that we purchased. Our scope 3 might be faculty and student commuting. It might be business trips. When you go on a business trip, you're contributing to greenhouse gases, but you're not necessarily flying the plane. So that's the thought process behind that. And I pulled this diagram from the Greenhouse Gas Protocol book, A Corporate Accounting and Reporting Standard, the revised edition. And it just shows graphically your scope 1 is direct emissions, scope 2 your utilities or your electricity, and then scope 3, again, everything else. Does anybody have any questions about setting up the scope or the boundaries? Yes?
Scope 3, is it like even people driving to work?
You could include your commuting to work as a scope 3. Scope 3 is really set up to be, it's optional. It's optional. It's not a scope 1 and 2 are generally required to be reported if you're in any sort of registry, but scope 3 is whatever you might want to look at. So if you're the university and you want to include, or a company, you want to include people commuting to your location because you may have some control over that. You might say, well, we're going to go to a 4-day work week and we'll work 10 hours a day and everybody will not drive on the day that they're not here, and look how much greenhouse, we'll save greenhouse gases that we are affecting because we made this decision. So things that the best way if you're doing a greenhouse gas emission is to look at things that you might be able to influence even though you don't control them. And if you can measure those and get a good sense of what's happening, and then look at what are we going to do and estimate how will this influence and how much benefit will it get. So why do we have scope 1, scope 2, and scope 3? Well, if you're a large corporation and you have a facility in 3 different states and 2 different countries, or you're a state and you want to do a statewide inventory, if everybody follows the rules very carefully and they call their scope 1 emissions a scope 1, their scope 2 emissions scope 2, and their scope 3 emissions a scope 3, then you avoid double counting. So in this example, it's an electricity example. You have generator A who generates 100 megawatts of electricity, and in doing so, in combusting the fuel to create that electricity, they emit 20 tons of carbon dioxide equivalents. Well, they count that 20 tons as their scope 1. You have a broker in the middle who doesn't do anything except for buy the 100 kilowatt hours or the megawatt hours and then sell it. So they can report their 20 tons as optional, like, well, we're in this process, but we don't really have any effect on it. When they sell the 100 megawatts to the utility owns transmission lines and a distribution system, and they use 5 kilowatt hours to for that purpose. So it's like purchased electricity. It is purchased electricity to them. So that's a scope 2. The emissions associated with purchasing that electricity is their scope 2. And then they sell the 95 megawatt hours. And again, that's purchased electricity, so the end user reports it as scope 2. So if you add up all your scope 1, 2, and 3, you see that you have 20 tons in scope 1, and you have 20 tons in each user's either scope 2 or scope 3, so you're you don't have double counting, and if you wanted to count all the scope ones, then you should have a good big picture. So that's the purpose of trying to divide it that way, so that when people put different things together, they can try to have some certainty that they're not counting things that are already counted and then add them together. Any questions on that? So step 2 is to identify your sources. Again, scope 1, your boilers, your furnaces, your heaters, your flares, whatever you're doing that would put fuel into the air. Mobile combustion, if it's happening as part of your process on your facility. So if you are hauling logs from your wood lot to your chip mill at a paper mill, then that transportation is scope 1 for you because you own it, you're using that fuel. Process emissions, if you're catalytically cracking petroleum, emissions from that process. If you have a calcination step in a cement manufacturer, that's emitting CO2. So those are things that you are actually doing. And your fugitive emissions, you have equipment leaks, you have a coal pile, you have wastewater treatment that's emitting methane. All of those would be your scope 1 emissions. Your scope 2, purchased electricity, steam, or heat. And your scope 3 would be whatever you decide to measure that will be of use to you in your study and for your purpose. And that goes back again to setting up your boundary conditions and deciding what and why you're measuring. So once you have your boundaries and you know your sources, you're ready to decide how you're going to do your calculations. And the best way is to directly measure your greenhouse gas emissions. And that's relatively uncommon, but it does happen. I'm working with a company right now, and rather than using emission factors for their greenhouse gas emissions, they have continuous environmental monitoring system on their stacks, and so they're able to look at the concentration, the flow rates, and get a good estimate that way. But for many companies, that's not real common. Another approach would be a mass balance or a stoichiometric basis specific to your facility or process. And for some processes, especially if you have process emissions, that's the best way to estimate, well, I'm bringing in so much limestone, I'm making so much lime from that, so mass balance, I know how much CO2 is from a process standpoint. So you can use that method too for some things.
That's like a basic chemistry equation. We have all
Yep.
this, and this has to come out of it.
Yep, exactly. Yeah, all the chemical engineers should really, I like that part. But the most common way is to look at your bills, your purchasing, and say, well, I purchased 100 pounds of coal, and I think I used about 100 pounds of coal. And the EPA AP 42 says that it's 0.085 pounds of carbon dioxide per pound of coal, so I'll multiply my coal by that factor, and now I know how much CO2 I emitted. And you can get emission factors for your methane and your nitrous oxide and your other greenhouse gases also. So that's the most common way, is to look at your fuel use.
Is this 0.085, is that an actual number that's used?
That is an actual number. I grabbed it rather quickly, but I think it's accurate.
Seems small to me.
I think it's right. But I might be off a decimal because, like I said, I was putting the slides together pretty quickly. So I wouldn't take it and use it without checking it, so please don't do that. Sources for emission factors. The Greenhouse Gas Protocol website has tools, and they actually have spreadsheets for different industries that have factors, and they're set up to help people document their greenhouse gas emissions. So that's a good place to look if you're interested in just seeing some of the tools that are used. I've looked at those and used data from those that companies have presented to me, and I think they're pretty good. The company that I subcontract to that does a lot of life cycle studies uses the EPA AP42 emission factors, and those are commonly used also. And then the Department of Energy, along with their voluntary reporting system, puts out emission factors also. So there are three good places to look for emission factors. Any questions on the emission factors? Or so once you decide, you know, your sources and your boundaries and your emission factors, then you start looking for your data. And again, you're looking for your purchased quantities of commercial fuels, and then you assemble the appropriate published emission factors to go with the types of fuels that you're using. You look at your metered electricity. When you are trying to calculate the emissions associated with electricity, traditionally with life cycle assessment, we use the fuels for the U.S. average with the mindset of it's all one big grid, and the electricity goes into it, and it goes where it's needed for the purchaser. So we used, and it's a lot more complex now. Now we frequently use a regional grid, which is a subset of the transmission area that is more concentrated, so that you get those specific fuels. We have companies that have told us, I have a contract with an electric utility in Canada because I want hydropower, and so I just want to use the fuel from my supplier. So the mindset is changing in the work that I do, and the practitioners I've talked to recently are pretty much of the same mindset, that you get as specific as possible with your electricity supplier. So instead of thinking what's a big grid, it's like, well, who's my contract with and what fuels are they using? And if you can't get to that level of detail, then you use a regional grid. That's great if you're doing a greenhouse gas inventory for one facility in one place. The types of studies that I do are often life cycle product studies, and we want to know the greenhouse gas emissions for cradle to grave on this product. And when you do that, for the client's own specific locations, we'll use the regional grids, but for all the chemicals that they bring in, we use the national grid, because our thought is that they're probably bringing in from suppliers in enough different locations that it's a good estimate. And we just honestly can't track down every single supplier, get their regional grid, or they wouldn't want to pay for the study, because it would just become so data intensive that it would cost too much. So that's how we handle it from a life cycle basis. Scope 3 emissions, as you said, if we add commuting to work, then we would look at, well, how many people do we have, and on average, how far do they drive? And then we get the average miles of driving and take an average miles per hour for the, an average vehicle, and you calculate that way. So it's not incredibly accurate, but it's probably a good estimate. And if you use the same method the next year, when you say, okay, we're driving one day less a week, you can start seeing some estimates for trends. And so once you have your data collected, I guess I should say a little bit more about the data collection. Is the devil is in the details. We usually, when we're working with a company and we want data from them, we send them a nice form and tell them how we want the data. and over what time period, and but then we get the data and it comes in a lot differently than we ask for it, so there's a lot of back and forth to clarify it. And that step's very important when you're collecting data, because if you just take data and say, okay, this is what they gave me, and you don't do a sanity check and say, well, I've never seen a mill use this much of this type of energy, I better go ask them. Collecting data for a paper mill recently, was going through all the details and asked my contact at the mill, well, I see that you bring in logs and you have a chip yard, but I don't see in your details that you have any electricity or fuel for your chip yard. Is that already combined in the other energy data that you gave me on this other form? She says, oh no, because the chip yard records are separate from my records, so I don't have access to those, so I don't know the answer to that question. You'll have to talk to the chip yard operator. So I went to, I got his phone number, I called the chip yard operator, and he goes, well, I don't know. I get the bill and I know how many dollars it is, but I don't get the detail of how much electricity is it. You'll have to talk to our accountant. Maybe she can tell you. And so you talk to 3 or 4 people before you finally say, oh, well, your annual kilowatt hour usage is this much for this part of it. So in collecting data, people who are very detail oriented and can look for these things and ask the questions, you'll get a better study because you have better data. And it's always, for any kind of study, garbage in, garbage out. So the better quality data you have coming in, the better quality your results are going to be. So your goal in your calculations is to get your units of carbon dioxide equivalents for the processes and the activities within your chosen boundaries, and given the, what you've decided your study is going to include. And there are, as I said, calculation tools and guidance available. The Greenhouse Gas Protocol Initiative website has some. Some companies that I work with are developing their own tools because they intend to do this year after year after year, and they want their own personnel doing it. And then consulting firms, like the consulting firm I subcontract to, Franklin Associates in Prairie Village, they have their own set of models and tools that they use that are proprietary. So that's kind of what you use. Usually the tools are they're spreadsheets. They're linked spreadsheets that help you track and calculate everything so that when you end up with some summary numbers, they make sense. So a simple example of the calculations, and these numbers are not real, and I didn't even name the fuel because I didn't want to confuse anybody. But for example, you have 100 gallons of fuel that you're using, and you have some emission factors. So you multiply your emission factors by your quantity of fuel, and then you know your pounds of each type of greenhouse gas that you've measured. Carbon dioxide, methane, and nitrous oxide are the most common, and they're usually, carbon dioxide is usually the real driver for your bottom line results. Sometimes methane will contribute significantly. In most cases, I haven't seen nitrous oxide contribute a lot to the bottom line for the studies that I've done. And then rarely we get some of the other gases that have enough emissions that they really make a difference to your bottom line and the place where the decision making is occurring. So you multiply all of your different amounts of greenhouse gases by your global warming potential factor. So carbon dioxide, that's easy. Usually there aren't any mistakes on that one. Methane, multiply by 21. Nitrous oxide, you multiply it by 310 because that's the second assessment report factors. And then you have your CO2 equivalents for each gas. A lot of the Greenhouse Gas Protocol the standards require you to report the amount of each type of gas as well as the CO2 equivalents. They also ask you to report your non-fossil, your biomass CO2 separately. And I didn't help in putting that standard together, so I don't know the reasoning, but that's how it's written. And then again, if you're reporting any place publicly, you should probably convert to metric tons of CO2 equivalents, so you're on a standard basis with other people who are reporting. So that's an example calculation. Any questions so far? Step 6, you report your results, and I mentioned corporations because it's a lot of work to do an inventory across a lot of different facilities and pull it together and report it in a way so that your top level decision makers can make some decisions, and so they usually have to gather and summarize and pull things together from a lot of different locations. And some of the things that would be included in a corporate level report are different than in a facility level report, because when I report to the engineer at the facility, they're looking at it saying, oh, well, my wastewater CO2 equivalent is this, and they want enough detail that they can go back and say, well, yeah, I guess that's the right number, or why does this mill have 20% more greenhouse gases than my mill, and I want some comparison down in the details. So a report that we give at the facility level has a lot more detail than something that you would report as wrapped up for a corporate level. So this is an example of some of the things, like a brief description of what are the emission sources. Did I leave anything out, or did I specifically include something that wouldn't normally be included, and why? Do I have comparative information from previous years, because your decision makers always want to know, well, are we doing better, or are we doing worse? What reporting period are we covering? Trends. We have business targets. Are we going to hit those? There are uncertainties in greenhouse gas inventories. There's uncertainties in the data that you collect. There's uncertainties in the emission factors. There are uncertainties in the global warming potential factors. So a discussion of that, because those numbers have a pretty large error bar around them, and that's important, especially if you're making marketing claims. That's important to remember, is that you have to look a lot better than your competitor before you can go out there and say, well, we're really better. Jim?
Are there industries that you're kind of find yourself being surprised that they were so big or relatively smaller? Or?
Usually when I do a study, I'm always surprised by something, and it's hard to say what it is. Sometimes it's that, oh, this process step that I thought would be relatively insignificant is a huge contributor, and that surprises me. Or my mindset was always that this product would be better, and it's not. And it's kind of fun to have enough of the details to know why. And that's part of doing these studies, is that when your client comes back and sees something that surprises them, you have to be able to explain, well, it's happening because this is where the data is and this is what it says. So yeah, I get surprised a lot. And so that kind of wraps up what I wanted to say. I mostly was hoping to give you just an introduction to the topic and enough information so that if you're truly interested in greenhouse gas inventories, some of these resources would be good places to look for more information.
Well, thank you.
All right.
So this is a relatively new field in the sense of 10 years ago there was very little of this going on.
10 years ago, we were on the downside of a wave of life cycle assessment being a very hot topic to kind of losing its appeal, and now we're on the upswing of greenhouse gases being a very hot topic.
And has the greenhouse gas emissions always been a part of life cycle assessments?
They have, but I was doing life cycle assessments about 13 years ago. It was my job as a consultant, and when at that time, as I was leaving that job, we were starting to take our greenhouse gases and apply global warming factors and put them on a carbon dioxide equivalent. Prior to that, a few years before that, so say 15 years ago, they were just part of a long list of air emissions, like here are all your air emissions from the process. And mostly people were looking at their emissions for more toxics. The greenhouse gases weren't really seen as a major problem. We were looking for, oh, why am I emitting mercury? And oh, that's because...
More health risks.
Yeah, more health risks.
Yeah.
So...
Okay. Any questions, comments? Yes, please.
When you hand off your information, your report, what do the companies usually do with it? Do they just want it so they know, or do they try to utilize it?
A lot of the companies we work for will look at it as for information that will help them improve internally. A good example from my work in life cycle is Procter & Gamble. And I don't know if you all remember when we used to go to the store and buy a box of detergent that was like this wide and this tall. And they started doing packaging studies saying, well, we put a lot of filler in our detergent. We could concentrate it and have a package half that size. And they're concentrating it even more and getting their packaging smaller and smaller for the same amount of service for the customer. So I do see companies, Coca-Cola did a lot of work on their packaging for their food and beverage products using life cycle assessment. I'm seeing the same thing in the global, in the greenhouse gas inventories, as we have companies coming saying, well, I want to know what's happening at this mill and this mill and this mill, and then we can make improvements. I want to know if I put recycled content into my product, how is it affecting global warming? Because we're not really sure that that's the right thing to do. So I have that, but also I have companies that are like, okay, here's my product, here's the competitor's product, and finish this study because we want to make some marketing claims. So when that happens, one of two things happens is they look at their study and say, this isn't the answer we wanted, and the study is buried very deep and it never sees the light of day again. Or they'll look at it and say, all right, how can we get this to the public because we are looking greener than our competitors. So those are the two things that happen if you're going for the competition.
Is it ever just like to see how efficient the company is, to see how much money they're wasting in things that they don't have to do?
That happens, I think, but it happens outside of my area of expertise because all of the studies I do don't actually look at it on a cost basis. And there are some practitioners out there who look at all of this and then say, well, let me put a dollar value to this waste, and to the extent that your consultant can do that for you, or you can do it yourself when you say, well, I can save money and help the environment.
Mm-hmm. Money appeals to people really well.
Yes, it always does. And generally, if you can be more efficient, if you can save resources, you're going to save money because things cost. So people who are very, very frugal are the most environmentally friendly people in the world. So.
Okay, thank you. Next week we have Dr. Ray Perotti from KU, and he'll be talking about Native American perspectives and sustainability. I think that'll be very interesting.